1 volt at 1 second, or 1 watt. So that's a joule, a watt second, a coulomb, and a farad. So with that in mind, half of the energy is in magnetic and half of it is in electrical. So the 0.5 there is taking care of the fact that we're using the electro end of it, and it's half the energy that's there. The other half is in magnetic. So with that in mind, we have a capacitor which has a certain portion of a volt. See, that's like if it was 1 volt, it would be 1 with the decimal point, but the capacitor is showing 3 sets of zeros basically there with the 1 interspersed, which makes it 10 microfarads. Okay, then the 100,000 would be the voltage. It could be any voltage. It could be 100 volts, 1 volt, or 25 volts, or whatever. And then if you square that, and then you have to further go to times the cycles per second. And after you've done all of that, that tiny charge that was there, each time it cycled, it adds up, it becomes cumulative. And that's why your capacitors, even though they don't appear to have a lot of electricity in them based on the fact that, say, they're 8 microfarads or whatever, if you repeat that enough times in a second, it becomes cumulative, and all of a sudden you have hundreds of thousands of volts that are available to you. And they're available, you're outside of the system which you were to begin with, so the amperage at that point depends on the degree to which you ground that capacitor to the earth. If you should touch it and touch an earth ground at the same time, it will cook you on the spot. So you don't really want it to unload at a very fast rate. So what you do, you choke it back with dividers so that only a limited amount will pass through the load which you're actually wanting to do the work for you. And at that point, you have useful energy. And here's some of the benefits which give you something to think about. In the world of politics and social mixing and that sort of thing, as far as governments go and such, there are really only 3 basic things which are necessary in order for a large group of people to function. One, they have to have water, they have to have food, and they have to have energy. And the first 2 are largely solved when the third one there, energy, comes into position. The have-not countries, as far as food and water are concerned, if they have energy, they can usually fix the food and the water problem. And most of the international problems as to countries which have and those that have not all tie into those things indirectly. Now, this particular system here has the ability to heal those problems in such a way that they're no longer third world countries. It basically makes the whole world energy efficient, energy sufficient, and with that in mind, the food can be produced and the water would be available for drinking. You can make it from salt water, or you can drill for water wells, or you can build with your electrical equipment, you can build reservoirs and all sorts of things, so that the 3 major sources outside of politics and religion that enter into world politics would be water, food, and energy. With that in mind, what we can do, if we have some lights now, we'll go to these devices and I'll demonstrate them and let you see what useful energy can do for you. Okay, can we have the overhead lights? We're going to stop in a little bit, and I'm sure there's going to be a lot of interesting questions. If there aren't, I'm going to be disappointed. The device which you see here in the small suitcase requires an earth grounding. So I've got a one-wire deal that goes into a 3-hole plug back there, and it's using the center plug or the earth grounding. If anyone has any doubts about it, they're welcome to come up and see that there's no energy coming from there. Hey, anybody want to? Can't hold you have to put a certain amount of pressure against it in order to make it work, and I can't do that, but you can. And I would estimate that that's probably useful energy.
How big is the battery that's running that?
It's a 12 volt, a minimum size, the smallest of the 12 volts. Do what?
4 ampere hour?
It's more like 6. But I use more than 6 amps right there. Okay, I think there's somebody here that brought a meter, and they're going to check me out here and tell us how many amps this thing has and how many volts it has. If they will come up, I'll stand aside and let them tell you. If anyone else would like to bring their voltmeter and amp meter, go ahead. Okay. And if anyone else would like to find out what's here, do what?
I have to get inside of it to reach with the...
No, well, right here's where you're going.
Just want to get inside of it.
Well, let's see. I'll tell you what we'll do. We'll hook it on like this, maybe. You want to...
Just want to measure current then?
Yeah, well, we're more interested in amps here than anything else, because that's what okay, well, let me hook this one on first, and then see.
Check me here before you plug in.
Okay, you're in good shape?
It's like around 20 amps common scale there.
Are you okay?
Yeah.
I think you're okay. Okay, if I can touch those things there, we'll see maybe 30 amps. I think there's something that we're not making contact with here. We may not be able to measure this because I should have brought along a wire that sticks out where we can. Let me see if this other one sticks out farther. Okay, we're going to put that one down there, and that one up there. If I can make contact here, we'll be able to read the amperage.